So today we will see this diabetes data and we will implement Gaussian live base. Okay, live base model. So first of all, we have to analyze the data itself. So if you can download this data from the Kaggle sites or on net, you can search and you can download. So once you download, you will find this .csv file like this. So there is these are the attributes. So total there are 9 attributes which we are relating that a person's are diabetic or not. So what are the attributes? First is the pregnancies, second is glucose, third is blood pressure, fourth is skin thickness, fifth is insulin. This is BMI, body mass index means something if what is the person's weight if with its height. Okay, this is called body mass index. So this is also a determining factor. Okay, like there are some criteria. If your height is 5.4 inch, then your weight should be something 64. Like this table is there actually for body mass index for a healthy person or what should be required. So this body mass index then is diabetes pedigree function. This is a function actually this is related to some test that will determine that a person how what are the chances that a person may be diabetic. This is when test is done, this data we can and the age of a person and finally the outcome. So there are total 9 attributes. Okay, so first you have to understand the data and analyze the data. So this is your outcome. Outcome is your see if you see the last column, the value is 1 0 1 0 1 0 1 0 1 1 0 means the value is either 1 either 0. So 0 is for non-diabetic and 1 is for diabetic. Okay, so this data is if you find the following features are there: pregnancy, that how many times a person women are pregnant. So pregnancy is also a determining factor for diabetic person. Okay, these are very considerable because most of time it was observed when a girl is pregnant, then there they may be the diabetic that time because they are taking more intake than it is required. Okay, next is the glucose. Glucose is plasma glucose concentration over 2 hours in an oral glucose tolerance test. So this is actually some types of tests are there. If you what is your glucose level after 2 hours of a meal? So that will also decide. There are some range blood pressure, diastolic blood pressure. But what is blood pressure? This is measurement of blood pressure of a person. Skin thickness. Skin thickness is in mm. This also is taken as a feature or attribute to decide the person may be diabetic or not. Insulin. Insulin will be tested with your 2 hour serum insulin. Okay, by blood test. Body mass index, weight in kilogram, and what is the height. So it is related like this. कित, कितनी हाइट है तो कितना वेट होना चाहिए. Diabetes pedigree function, a function which scores likelihood of diabetes based on the family history, age, age in years, and outcome. Class variable 0 if non-diabetic and 1 if diabetic. So these are the features, and outcome is either a person is non-diabetic or diabetic. So there are many ways you can do this test. So I observe that. So this is your outcome, and this is first eight attributes. But first attribute, eight attributes will be taken to analyze the data, and then we'll train our model taking this first at eight attributes. See, there are many cases where we can decide that which feature is most significant, because if we can extract some significant feature, our model may be less complex and our analysis also will become more efficient. So this is one area where we can think. But in general, in this example, we are taking all attributes. So this may not be the case, because in general, the data is given. Data is given, there may be uh, many attributes, but all attributes may not be having that much importance. Okay, for being a person to be diabetic. So here in this data, we observe, if you observe the diabetic results, you'll find that the person whose age is more than 40 years, they are more likely to be diabetic than rather than a person whose age are less than 40. In that also, below 30 years of age, mostly very few people are diabetic, in rare cases. And then 30 to 40, very uh, that also less, but maybe more than the person who are in the range of below 20 years. So similarly, if a person more than 50 years of age, they may have be the likely to be a diabetic. Again, the one factor, other factor may be diabetes pedigree function. That is, it's related to your family history. If your parents are diabetic, so there are chances in that case for you that you will also be diabetic in future, maybe after 40 or 50. But more likely there is a chance. Similar, Similarly, glucose levels, these are the testing factor, but this is the historical fact actually. Though what the last two attributes, age and family history, that is diabetes pedigree function, these are the historical fact we can consider. If you observe, then you can find that there are people whose age are more than 40, they are more likely to be the diabetic, and who are having their uh, history of diabetic, they are they are more likely to have a diabetes. Okay, so these are the other factors. This also you can think what you can do. So first thing is to analyze the data. Okay, so these are the data is given. This is here, it is in tabular form. Okay, pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes, age, out, and this is your final outcome. Okay, So glucose C 148, what it is? Diabetic. This ratio is 0.627, it is diabetic. This is ratio is 0.3510. So this is 85 glucose level. This is 0. So non-diabetic. So we can correlate these things. Okay, for taking this extracting the features which are more significant. For that, we can analyze this data by using the graph, or we can draw some histogram like which range for glucose level, for which range, like 110 to 120 or 120 to 140. We can draw a histogram. Then we can analyze in which range the people may be diabetic. Similarly, in this diabetes pedigree, this also body mass index histogram, insulin. So these all cases we can draw and analyze the data. This is the first steps. Okay. But here in this example, we'll take these all 8 attributes as our training for training. This one, pregnancy, glucose, blood pressure, skin, insulin, BMI, diabetes, age and outcome, right? So you can see how much the data is there. Data is large enough. So there is 769 records are there. Okay, total records are 769. So when you will download this file from the sites Kaggle or some other sites, so there will be some detail also given that which attributes is what and why it is taken and what is the range of that attribute. Okay, these all things are given there. We can analyze the data, and in some cases you need to normalize the data, like, okay. So here we can use the classifier. Only two classes are there, 0 and 1. So diabetic and non-diabetic, right? So how to do this programming? Programming is, see, this is the our program. Okay. So you already know to analyze, to develop a model. First we have to read that file. For that, we'll take library pandas as PD and data is pd.read underscore csv diabetes.csv. So this will take the data from your disk and read the data. Now here what we are doing, we are separating our data in the form of X and Y. Okay, what is the X? Is the data of location from 0 to 8. Okay, 0 to 8 value means first. This is your training data. Training data and test data means first at attributes we are taking as a training data with value, and that we are saving in an attribute X, and similarly in Y. This is the data head. We are seeing the data, what kind of head. Head will give the some first 10 row, okay, of the data, what data has been extracted. Okay, they see this is the output. Next is we have to import train and test split. This from your sklearn library. From sklearn.model selection, import train test split. So these are the attributes x train, x test, y train, y test. Okay. So train test split is done in the variable x and y. Test size is 0.33 means 33%. Okay, test size. So remaining will be 67% will be for training. And these are some random variable we have taken. Okay, this means 0.33 we are taking for testing purpose and rest no. So the next will be data is dividing here. Now we'll apply the naive Bayes classifier. Okay, so this classifier for this to use this classifier, what we have to do? We have to import this function scalar dot naive Bayes import Gaussian naive Bayes. Okay, then we can use this function directly, right? Now this classifier variable is set to Gaussian naive Bayes classifier. So classifier dot fit x underscore train and y underscore train means this is here we are doing training. Now we are predicting. Predicting means see we divided the data in the two parts. What that part means if you can see here. So this is your data. Okay, this is your data. How much was record there? 799. What we did? See, there are two steps in training the data. First is training and then testing that model. Then after that, see this data we are having nearly 800 records, 769. Okay. So out of this 769, 33% is taken for the test. So 63% is taken for what? Training. So training data is kept in X variable, capital X, and testing data is kept in Y variable. Okay. So how much if I taken 67%? So what will be the 67% of 769? Okay. So it may be how much? This will be nearly 460 records. Okay. Out of this 769, there will be nearly 460 records we have taken for the training and for rest data. So nearly 200 and so nearly 300 data is taken for training purpose. So this data is divided randomly. Random state is given 42. So this is a random variable. We cannot determine that how random it is doing. For that detail, we can go to the Python library and can take some programming guide that what is its significance in randomness. Okay. So this data is divided. Hmm. So classifier dot predict. So after this prediction, so see this is your training data, X train and Y train. Next we have to predict of the rest of data जो 300 डेटा हमने दिया था that will predict. क्या predict करेंगे इस classifier इस model जो this model we have developed here by training using these two functions. Okay, can we test predict x underscore test data. See, okay, and then we'll print the output of the prediction. So this is the output. Okay, so see, what is the x train? X train is the g एक variable output variable को छोड़ के the initial 8 variables are those. Okay, what is the x test? X test is the outcome of those 460 records. Okay, that we know. This input and output both are given to train and test and to develop the model. After developing the model, okay, we predict y. See what we are doing. The predict function, what it will do, it will use this developed classifier. Where it is developed, it here it is developed, or we created this model here. Okay, so with this model, this CLF, okay, we predict the rest 200, sorry, nearly 300 रिकॉर्ड जो हमने टेस्ट के लिए रखा था, और we will not give the output. Okay, इसका आउटपुट क्या था, 0 था, 1 था, no, I will not give. From where it will come? It will come from this classifier key, what it output is giving, and then this function will match with the actual output. Okay, so actual output से match करने के बाद it will predict what is the accuracy. Okay, accuracy of this classifier. For calculating the accuracy underscore score, this we have to import sklearn dot matrix import accuracy underscore score. Okay, why predict classifier print y predict, this is the prediction. So how much record is there? Actually, 1, 2, 3, 4, 5, 6, 7, 8, 10, 15, 16, 17, 2, 3, 4, 30. 1, 2, 3, 4, 5, 6, 7, 37. 3, 4, 5, 6. 37 into 6. 37 into 6, or you can say 35 into 7, near about. Nearly 200 something records are there. So these are the test records. Okay, these are the test records. And finally, we are calculating the accuracy of this model is 73.62%. So let we change something. Randomness, suppose like 30. And what is the output? See, earlier it was 73. Now it is 74. So this is the better model than our earlier. Now I will put 20. So accuracy is increasing. I'm decreasing the test size. Accuracy is increasing. This model is actually not behaving in good manner. Okay, let's see again. Do 10. What is, oh, accuracy decreases. See, at 10, When I put the test size 10, the accuracy become 70. So this is not good model right now. See, when I put test size 10, see here, this output is of the test size, test data. So it reduces because अब जो है only 10%, 70, nearly 70 records are this. So either we counted this is 37 or 35, nearly 70 records are there. So if we increase, so what is the highest? Let us decide what is the highest. What highest we can get. So I will put 15. Oh, good enough. 78, 78.45. Okay. Now I'll increase because after 20 it is decreasing. So I will go slow here. 16, 78, same. No difference. So I'll put 14. Now it reduced. So 17. What is the accuracy? 74. 19. 76. 20. 76. So I found that at 15, this is good, giving the best result, 78.45 accuracy. So this is the one variable which changes. Now I'll see, I will change this random state. Random means, see, random state means we are taking sample random. I put 0, no random. Oh, 80%. Good. Now this I will make 20. Good. So why I am doing these all things? My accuracy must be as more as possible, as much as possible. Because actually it must be more than 95% to use in real environment. This is the things. So I will put this 10, some randomness. So randomness will affecting. So what see these are kept 42 with some 78. So if I put 78 to 43, 72, see 41. Okay, so this state is kept as by the experiment. So in earlier you don't know these variables. So basically you have to check by changing these variables that where you are getting the best accuracy and how you can increase the accuracy level. Okay, these things like this you have to do in real time environment. Okay, right. So what we did is your data. Now see, I have taken head attribute. Now I want to exclude some attribute. Suppose pregnancy, glucose, blood pressure. I want to take this one, this three. Okay, for training and testing purpose. I want to take down last three. I want to last three. One, see these last three. because what I think these are the more significant as per history. So last three I want to kept 1, 2, 3, 4, 5 out. Okay, this is just I'm saying historical or one opinion, but in actual we have to analyze the data by some tools, some mathematical formula, correlation, covariance, standard mean deviation. These all will calculate that which is more significant for these problems. So can we change? I want this only. Hmm. Now suppose I want to take first. I don't want to take A's, so I'll put 7. I will put 7. Next I'll run. So accuracy decreased 6.03 means significant. A contributor was that. Oh my god. Okay. So this way we can analyze our data also. Which variable is more significant? Like this. Okay. You can practice and final aim is to get the more accuracy. Okay. So for that you have to do a lot of hard work to get the accuracy more than 95% or 97%. Okay. What is the iloc method is retrieving. So I can take it here. What is mm, so actually I want these three. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Okay. I want this one. 7, 8. How can we do? Let's try this. This also I want 6, 7, 8. Okay. That I will comment. Yes, and what is error? Mhm. So there are some methods, okay, to try this. Mm. So all values, what error is there? Value error, bad input. Some syntax problem is there. Okay, try this once. Okay, in this what we have done. So only this eight column we have taken. Okay, if we take four, what will be the say output become 40. So from where we can see that some attributes are good, some attributes are not. So how we'll decide? Okay, so we, we try this with mm, we try this with for last three column. Okay, last three column. Some error is here actually. We try some syntax problem maybe. Okay, 1 2 it is working. Okay, now I want 3. So accuracy is 71. I want to take 4 column. So accuracy again decreases. I want to take 5 to 8 column. So again decreases. Okay. So I want to take 6 to 8. Again decreases. I want to take 7 to 8. Again decreases. So it's better to take 0, 78. Is there any other way? So random state 42. Okay. Similarly, you can draw the confusion matrix and those all things. Okay. And then you can analyze for each and every steps. Okay. Like this you can do. You practice and try to get accuracy more than 90 at least. Okay. So this is the data. Okay, this is the data. Similarly, there is one more data, head brain size. Okay, that also is see how you can do those practices. Right. So what we have done today? We have applied the Gaussian Naibus. Okay, where by using the Python using Panda library. Okay, so it's very simple. What you are doing here? Here we are taking the first 8 attributes and in Y also. Then we are using the train test split. This is one function, train test split, where these all attributes are actually is the same. We will return. This is the standard way of programming. So no change. Only we have to take care of this X and Y, that which columns we are taking or which columns are rows also. So generally we are taking all rows, all values, all samples of the column, all columns. Okay. So we can change. How we can change that? So if we cannot do this at random, using some analysis, we can change that. I want this column, this column, this column for greater accuracy. Our final aim is to find the greater accuracy. Okay. So like this, and then we will put this X train, X test, Y train, Y test. These are the 4 variables. After the train and test steps split, here we are splitting the data in now in this size. This is 0.15 means 15 to 85 ratio. Now this ratio is 15 to 85. This is some random state. This value we can change also. For 42 it is 78. So if you put 142, what is the value? See, accuracy increased at T2. So this is the better one, better model. Okay. So here is the here we can change, here also we can change. Okay, for getting the better accuracy. Next we are using the naive Bayes classifier, Gaussian naive Bayes. Okay, this you see, this is the basic naive classifier, and then we'll train this model using this function dot fit, and we'll pass the x train and y train, and now finally we'll predict. So for the rest of at, test size is 15, means 15% of data. For 15% of data we'll predict, and after getting the prediction, what we'll do, we'll find the accuracy. What is the accuracy of this model? So here what you get 82 point. So let's change some more. When we go up to 90%, 150. Now it decreases again. So 142 was the best till now. Okay, 82%. So this also we can change. Data also we can change attribute, which attribute we want to take or which attribute we don't want to take. Like these things we can decide. Okay. First task is you have to analyze the data. How to analyze the data? Using the tools. You can draw the chart, histogram, bar chart. Okay, like in age group, if you will draw age group with outcome. So you make a histogram that between the age group of 0 to 10, what is the how much persons are diabetic? Between the age 0 to 10 to 20, how much diabetic? Like this, 20 to 30, 30 to 40, 40 to 50. So if you analyze this data, so you can observe the data. Most cases see 50 diabetic, 31 not diabetic, 32 diabetic, 21 no, 33 no, 30 no, 26 yes. So you can analyze this in which range of the in which age range the person is more diabetic. Okay, by observing your histogram. Similarly, for each attribute we can do for each attribute, and this is the one simplest way to analyze, and we can decide if which attributes are more significant in determining these things. Okay, like we can use the matplotlib or SNS library to draw this diagram. SNS is now good because we can draw at a time all this attribute graph, and it is also looking very good. So C1 library you can use, or matplotlib, which one you want to use you can use. There is no problem in that. Okay. Similarly, you can download data of cancer predictions, and you can apply this model, and you can analyze or develop some good model. Okay, still this model is not enough to be used in real time because still accuracy is only 82%. This is not usable in real time environment. So your task is to develop a model in such way that accuracy actually must be more than 95% at least. This is the if very less accurate, then it must be 95%. So suppose using this naive base, okay, you are not getting, then what we can do, we will apply. There are two three wings we can think. We can apply some other machine learning algorithms first thing, then we will see what that is, what results are coming from that, if some improvement is there or not. Other is we can analyze this data. Data analyzing is very important. So which attribute is more significant? If taking only those attributes, is there any effect in accuracy? So in that case, we can say, okay, these attributes will take, and these attributes will not take, because it is giving good result. On those which are not significant for predicting a person is diabetic or not diabetic, so that we will not take. So for that, you will not do anything at random. You have to analyze data only, maybe by chart, maybe using some mathematical formula, how these two variables are related. If two variables are related or not related, or two variables are totally opposite. Okay, so this kind of thing we have to think. Okay. Basically, basically what is done, these variables what I told like test size and some other cross validation techniques can be used there. Like suppose I want to tenfold cross validation, then you can put in that variable, and then also some result may change. Like this random state we can change. Okay. By doing this, R see here this Gaussian knife base is already is there. Okay, there is that is the standard algorithm. We are using that directly. But even if you can write some new Gaussian knife base, okay, they are derived from it, then and it is giving some good result, and that is also okay, no problem, right? Then also this is okay, no problem. So in that case, that is more good because this is your work then. Okay. Similarly, we can use SVM, linear regression, logistic regression. So you have to think where we can use linear regression, where can use logistic regression, can we use linear regression here or not? Okay, just think which classifier we can use, which classifier is good for which problem or which type of problem. These all things will be considered, and this will come only with some experience. Without experience, we cannot do this. Okay, so next we'll see this head brain. Okay, head width and brain. This is the one example. This we'll see.